Hello students, let us discuss oxoacids of phosphorus. Phosphorus form a number of oxoacids. The important oxoacids are orthophosphoric acid, pyrophosphoric acid, orthophosphorus acid, hypophosphorus acid, cyclotrimetaphosphoric acid, polymetaphosphoric acid. The structures of these acids are given here. But how to learn these structures easily, that we'll be going to discuss here. So first, that is H3PO2. What we call this one? That is hypophosphorus acid. Now here, once you have learned this formula, look at this formula carefully. Here, there is one P double bond O. There is a single POH bond, pH. There are two pH. So once you have learned this one, we can make easily the structures for others. Let us discuss that. This is H3PO2. Look at carefully here. It have two pH. Now change one of the pH as POH. Now the structure, this is the structure for H3PO3. That is orthophosphorus acid. Now one more pH is that you change it with the POH like this. Now the structure, this one is for H3PO4, that is orthophosphoric acid, which is commonly called as phosphoric acid, that is H3PO4. So we have made three structures of oxoacid of phosphorus very easily. So how I told you, first you have to make the structure for H3PO2. Learn the structure of this one, H3PO2. Then replace one of the H as OH. Then it is a structure for H3PO3. Replace one more H as OH. Then it is H3PO4. So like this, three structures you can make very easily. Now next we will make another structure. So once you have learned the structure, this H3PO4, now which we have learned here, you need to make one more structure here. Make two structure of H3PO4 in this way. Little bit make closer so that it will be very easy to frame the other structure. Now here, the center, here you can find two OHs are there. From this, make the box for H of one and OH for other. That means remove water from here. When you remove water from that, one O will be remaining. Now this structure is the structure for H4P2O7, that is called as pyrophosphoric acid. So we made this a new structure here. So how we made this structure? Once again look at this one. So as we have learned for the structure for H3PO4, make this two structures, make it little bit closer, keep the box for removing water, remove the water so that one O will be remaining. This structure is called as H4P2O7. That is, the structure is called as pyrophosphoric acid. Now we'll make the another structure. For this, again we need H3PO4, but write it in the 3 times like this and make it in the cyclic form and make it this way that the OH will come closer. So like this we'll make it. That is the 3 H3PO4 is drawn in this way. Now here, remove water from here, remove water from here. So OH, when water is removed, one O is remaining here, one O is remaining here, one O is remaining. So you'll be getting the structure like this. So this structure is a cyclic structure, that is a structure which is called as cyclotrimetaphosphoric acid. Here it is a ring of 6 members, that is one phosphorus, oxygen, phosphorus, oxygen, phosphorus, oxygen. That is an alternate phosphorus and oxygen. It makes a ring of this. That is a hexagonal ring, and on each phosphorus there is a double bond and one OH. So we can say that this part is repeating. That is P here, double bond here, and one oxygen. This part is repeating. That is 1 P, 1 OH, and 2 O is repeating. So this is the repeating part of this one. So it make a cyclic structure here. So we'll make the structure very easily. So we have made the structure for H3PO2, H3PO3, H3PO4. So what we have find the changes here? Here there is 1 OH, 2 OH, and there are 3 OH. This is hypophosphorus, orthophosphorus, and orthophosphoric acid. So like this we have learned the structures for all these compound acid. So this table is given in the textbook. That is the name of the acid, formula, and the oxidation state of phosphorus. When you look at here, oxidation state of phosphorus in this is +1. Here it is +3, +3, +4, +5, and so on. So these are the oxidation state of phosphorus which is given, and here the structure is explained. Now let us discuss the reducing properties and basicity in these structures. Let us take one example, that is H3PO2, that is hypophosphorus acid. The structure for this which we have already discussed here. Now the reducing property, the acid which contain pH bond that have a strong reducing properties. So here there are two pH bond, that is pH bond. So this acid which having pH bond have a strong reducing properties. So in this example there are two pH, so it have strong reducing properties. And the POH is responsible for basicity. So here there is only one OH, therefore it is basicity is 1. Because there is only one OH, therefore it is basicity is 1. Let us take the next example, that is H3PO3. In this, because there is only single pH, that is it have less reducing properties in compared to H3PO2, but it have 2 OH, therefore its basicity is 2. In the case of H3PO4, because it does not have pH, so it does not have a reducing property, but there are 3 OH, therefore its basicity is equal to 3. So like this we can find out the basicity and reducing properties we can compare with the help of the structure. So here the basicity, how much will be the basicity? Basicity can be found out by comparing the number of OH present in the structure. So here 4 OH are there, so its basicity is 4. So on the basis of this concept, usually the question arises in this way. It is one of the textbook question. What is the basicity of H3PO4? So first you need to make the structure, that is H3PO4, which we have already discussed here. Now here when you compare in the structure, there are 3 OH. Therefore its basicity is equal to 3. Next question. How do you account for the reducing behavior of H3PO2 on the basis of its structure? So here we need to discuss the reducing behavior of H3PO2 on the basis of structure. So for this type of question you must need to make a structure here. So make the structure for H3PO2. This is a structure. Here, reducing behavior that will be due to the pH bond. So greater will be the pH bond, they have stronger reducing property. So what we can say that in this, there are two H atoms which is bonded directly to phosphorus. That is these two H which is bonded directly to phosphorus. So this impart the reducing character to acid. So they have strong reducing properties because there are two hydrogen which is directly bonded to phosphorus. These type of questions are quite familiar in exams. Therefore, it is important such type of question should be done with the help of the structure. So, there is need to learn the structure properly here. And the method which I told you, that will be more easier to learn. So, this is all about this video. Have a nice day.